So we will just learn few numericals on nuclear chemistry unit. And the first question that we are going to learn is this. Okay, you can find the question here. The question is, how many years will be taken by a radioactive element to disintegrate into 12.5% of its initial amount? And they have also given you the half-life period, that is 1560 years. What they are asking to calculate, first you must know what they are asking here. In the question, they are asking to find how many years. That means you should find time t in years. Time t in years. Okay, time can be found in minutes, days, seconds, anything. But here they have mentioned that how many years will be taken by a radioactive element to disintegrate into 12.5% of its initial amount. And you must guess, whenever there is a percentage, the initial amount is 100. This is very, very important. Whenever they have given in percentage, initial amount of the radioactive nuclei is 100. I will just show you some of the important formulas, those things you must be remembering in your mind. See, this is n of t is equal to n naught e power. E is nothing but exponent e raised to lambda t. This minus indicates that the amount is decreased with increasing time. We already know this formula. I need not explain all those derivations and all. If I have t is 0 in the place of t, that is initial time, t is equal to 0 means what will happen? I will get only n naught e power exponential to the power of lambda 0, that wholly becomes as 0. Anything raised to power 0 is 1. This entire term becomes 1. So the number of radioactive nuclei present at time t is equal to 0 is n naught. Clear? Similarly, this is nothing but half-life period. T half is half-life period. That will be half of the initial amount. So these are the general formulas you must be much familiar with. Okay, in question they have given given you as how many years it will be taken, right? That I should find this t, correct? So we can have like this. In question we have given as 12.5 percentage. At what time it disintegrates? At what time this much amount disintegrate? I should find n of 0 is 100. N of 0 is 100 because in percentage, whenever it is given in percentage, initial number of radioactive nuclei will be 100. Okay, and half of this, that is 100 divided by 2 is 50. 100 divided by 2 is going to be 50. That is the number of radioactive nuclei uh, at its half-life period. Okay, and number of radioactive nuclei at time t is 12.5. Now we are going to find this t is equal to what? Is the question is clear? Is the question is clear? Yes. Now I will give you the correct explanation of the question here. Just you collect the data from the question. N naught, initial number of radioactive nuclei is 100, and number of radioactive nuclei at time t is equal to t, that is we should find, given as 12.5. And in the question they have also given additional thing, that is half life period is 1560 years. Just you keep on substituting in this single formula. We are just using one single formula here. If I have n of, just you plug in this 1560 in the place of t. Here t will be coming, and the formula is n of t is equal to n naught e raised to minus lambda t. In the place of t, if I put 0, it will be n naught. N naught is 100. Number of radioactive nuclei present initially is 100. Okay, and half life period is given as 1560. This is half life period. Then t half will be half of its original amount. Original amount is 100. So half of 100 is 50. Okay, half of 100 is 50. So n of 1560 in the formula I am just writing here. N naught is 100 and e to the power minus lambda. In the place of t we are substituting. In the place of t I am substituting t half. T half is given in the question as 1560. In both the places I should substitute the same. As you can see here, I have done here. In this area I have done. Okay, right. Now this will be 50, right? 50 is equal to 100 e power minus a lambda 1560. As usual, you bring 100 to this side because you're going to find lambda value. After doing all these things, you will have an exponential expression. To solve an exponential equation, just you take log on both the sides. You will have like this. Log of 0.5 is minus 0.3010 is equal to this thing, right? You should know this formula. In the general formula, you must know log a to the power b is b log a. Remember as log a. Okay, log of e power minus lambda 1560, where this lambda e acts as a and lambda 5000 sorry 1560 will be b. Accordingly we will write this, and log e is 1. It is simply 1, so you will end up as only this part of the equation will be written. That is over here you can find. By doing the cross multiplication, it is easy to find the value of lambda. Once you do this, take the formula. To this same formula, we have substituted the half-life period and found the value of lambda. Now we are going to have the number of, this is the final step. From here, it starts the final step. N of t is equal to n naught e power minus lambda t, right? In that formula, nt, number of radioactive nuclei to be disintegrated at some time that we should find is given as 12.5 in the question. Just to plug in here, and you will write in the place of n naught, it is 100 initial amount of radioactive nuclei, and write the substitute the value of lambda also. You will do all these things, you will do, right? And once you get the exponential equation, take log on both sides. Just find the same as usual you did for lambda, the same thing goes for t also. Finally, you will get the answer as 4680 years. 4680 years will be the time taken for the radioactive element to disintegrate. 12.5 5 percentage 5 percentage of its initial amount. Is that clear? Okay. So we will have one more question. We will have another question is, let me choose this question. Right. Now the question here, how many curie are present in 18.5 into 10 power 10 disintegration per second? What is the question? Just you go through the question. How many curie are present in 18.5 into 10 to the power 10 disintegration per second? So for this, you must know one formula, right? We all know 1 curie is 3.7 into 10 to the power 10 dsp. dsp is nothing but disintegration per second. From this formula, I can write two variety of ratios. 1 curie divided by 3.7 into 10 to the power 10 dsp. Another kind I can write as 3.7 into 10 to the power 10 dsp divided by 1 curie. So to convert, they are asking how many curie are present in this disintegration per second. 18.5 into 10 power 10. So for which, what you do is, this is the next step. Whatever I have given here is the next step. 18 point, I will just enlarge it so that you can see it clearly. To convert this DSP, they are asking how many curie. So to convert DSP into curie, I am using the same expression, divide 3.7 into 10 power 10. Okay, in order to cancel this DSP, I should divide it by DSP. So what I should use it here now, 1 curie divided by 3.7 into 10 power 10. Other one you should multiply with this. Finally, on doing the calculation, you will get 5 curie. You will get 5 curie. So I can write it as, therefore 5 curie are present in 18.5 into 10 power 10 dsp. Okay, and it can be very simply written as 5 curie. 1 curie is equal to 3.7 into 10 power 10 dsp. Therefore 5 curie is equal to 18.5 into 10 power 10 dsp. So there are 5 curie present in 18.5 into 10 power 10 dsp. Is it clear? This is a very, very important question. Very important question. And one more question we will learn. Just go through this question alone. With this, we will end up. Okay. The parent element is given as Pu244. This parent element emits 2 alpha particle. Read it carefully. It emits 2 alpha particle and 1 beta particle. You should write the consequent equation with the, finally you must also write the daughter element with its atomic number and mass number. So you should know that alpha emission, always alpha particle or alpha emission or alpha decay gives helium ion, helium nuclei. Beta decay always gives you electron, it emits electron. Alpha decay emits helium nuclei and beta decay emits electron. So same thing is given here, so we can find it. Plutonium 94 undergoes alpha decay. It undergoes alpha decay, that is, it must emit a helium nuclei. Accordingly, you balance the atomic number as well as your mass number. You will get uranium. Again, uranium also undergoes alpha decay because 2 alpha it emits. In the question they have given as it emits 2 alpha particle and 1 beta particle. It emits 2 alpha particle. These are alpha decay and the last one will be beta decay. So the thorium, the finally you are getting thorium in alpha decay. That thorium undergoes beta decay to form the daughter element, to form the daughter element protactinium, to form the daughter element protactinium of atomic number 91 and mass number is 236. Parent element is this and the daughter element is this. Okay. Uh, so that's it. We will close here.